Hey there, math assessors. It's Brandon Horn again. I'm going to give you a lesson in quadratics. Let's go. Kind of like my blue one, actually. Alright. 3, 4, 5. 2, 4, 5. 1, 2, 3, 4, 5. Gonna have to have it. Alright, so as you can see here, I just randomly drew a quadratic equation called graph axiom. Right here is the vertex, and this has two x-intercepts right here and right here, and there's also a y-intercept right there. And my favorite part about a quadratic graph is that by looking at the two zeros or solutions right there, you can tell what the graph is going to look like and what direction it's going to be facing, up or down. And that's about it. Thank you.
I have an additional question.
Yeah, sure. What's going on?
How do we know that those two are the x-intercepts and that the other one's the y-intercept? How can we identify those?
Because this is the y and x portion of the graph right there.
All right, so you look at your x and your y-axis to decide.
Yeah, exactly.
So an intercept is kind of like something in sports, sort of. It's kind of like sports.
There's interceptions in football, but this is math.
Can't this kind of relate to that, though? Sort of. Like a little football player going on the parabola and booyah.
Yeah, exactly.
Oh, I get it.
suppose you could do that in elementary terms, yes.
And how about that vertex? How do I know that that's the vertex, not another point?
Because that's at the point where the two lines go sprout different ways.
So why isn't the vertex right here?
Because that's where the vertex is according to the equation on the graph.
If I don't have an equation now, how do I know that it's the vertex?
Because there's an axis of symmetry right here, like an invisible axis of symmetry.
What does that do?
That helps you tell where the vertex is. And, I mean, you couldn't really have it over here because the whole graph would be out of whack. So if you drew an invisible axis of symmetry right here, I mean, this really wouldn't make sense over here.
Are there any points below the vertex?
No, the vertex is the lowest point on a quadratic.
All right.
Or the highest, according to
It could be the highest. What would a graph look like if the vertex was the highest point? How would it be different from this one?
It would be going downwards, something like this. I'm not gonna
You just give me a rough sketch of what that would look like.
Sure. And this would be the highest point right here.
So it would have a maximum instead.
Yeah, instead of a minimum.
So the vertex is always the lowest or the highest. That's what you said?
Exactly.
All right. Cool. Very cool. Anything else you'd like to point out about
No,
this
I don't
graph?
believe so. I believe this is pretty good.
All right. Thanks, Brandon.
All right. See you guys later.